Hello, before we get started, I just want to let you know that this lecture is part of a full module in our FE Exam Academy. The link can be found in the description. Once you go to the link in the description, you will have access to full resources for passing your FE exam, including a community of like-minded students, as well as a classroom section. As you can see, we have a practice exam, a TI 36 X Pro course, as well as each of the topics broken down, mathematics and statistics, engineering economics, and so on. We also have office hours, as you can see here, where you can talk directly to me and ask me any questions that you have for your upcoming exam. I can help you prepare for it so that you are ready to pass. That being said, now let's go ahead and get into today's topic. Hello, welcome to the next section of our FE exam review course. In this section, we are going to be covering centroids of area. So the concept of the centroid is pretty simple. It's basically the geometric center of a shape. However, it can be kind of tricky sometimes to find that geometric center or the centroid when the shapes are not very straightforward. However, in this lecture, we'll get familiar with how to solve for the centroids of several different types of shapes, and we'll become very familiar with this process. So let's go ahead and start off with question number 1. So if we go over to the FE reference manual, we can find the formulas for centroid of area right here on page 95. This is the section that we're interested in this case. So let me go ahead and write that down in our notes, and then I'll explain how to use these formulas. So here are the formulas that we just saw in the FE reference manual, along with a couple of explanations for what each of the terms means. So in this case, xn or yn refers to the coordinate for the centroid of a component of our shape. So here's what I mean by the component. So as you can see, this question is asking us about this entire shape, and the way that we solve for the y-coordinate for the centroid of this entire shape is by breaking it down into two rectangles. That'll make it easier to work with. As you can see, we have rectangle 1 and rectangle 2. Each of those is going to be a component that we use with this formula. So the way the formula works is we're going to sum up the x or y coordinate for each component multiplied by the area of that component and divide the entire thing by the total area of our shape. So that is the basics of how we're going to solve these problems. It'll make a lot more sense once we solve one of these step by step. So let's go ahead and start doing that. So in this case, we only need to find the y-coordinate for the centroid of this shape, so we don't need to worry about the x-coordinate at all. So let's go ahead and use this formula right here and apply it to our shape. So let's go ahead and start filling out our formula. So in this case, we need to find the y-coordinate for the centroid of these components. So here I drew a couple of lines that show what we're looking for basically. We're going halfway up each of the components, and we just want to know what the y-coordinate of these lines are. So if we look at our first component, the height is going to be 100 centimeters, so half of that is 50 centimeters. However, we're not going to write 50 centimeters in our formula. We actually need to add these 300 centimeters right here to that. So basically what we're doing is we're taking the height that we found for the y-coordinate of the component, and we're writing in the distance of that height from the origin right here, as you can see, from 0, 0. So now we have to multiply this 350 centimeters by the area of that first component. So that's going to be 500 centimeters times 100 centimeters. So as you can see, we have the y-coordinate for the centroid of that first component multiplied by the area of that first component. So now we move on to that second component. In this case, the y-coordinate for the centroid is going to be half of 300 centimeters, as you can see. So we know that that will be 150 centimeters. And then once again, we need to multiply the 150 centimeters by the area of that second component, which would be 100 centimeters times 300 centimeters. So that is how we fill out the top part of this formula. Then remember that the bottom is just the total area for the shape.
So we can find that total area just by adding up the area for our first component and the area for our second component. So this is what the formula looks like when we fill it out completely. Let's go ahead and put that in our calculator and see what the answer is. So the answer for this problem is going to be 275 centimeters. That is going to be the y-coordinate for the centroid of this entire shape. So if we take a look at the multiple choice, the answer for this one is going to be A. Moving on to question number 2. Now we need to find both the x and y coordinates for the centroid of our shape. So in this case, let's go ahead and split up our shape into a triangle and a rectangle, as you can see here. And then let's use our formulas to solve the problem in the same way we did with the last one. So let's start off by finding the x coordinate of the centroid. As you can see, we do have a triangle as one of our components. So the coordinates for that centroid are going to be found differently than they would be for a rectangle. We can refer to the FE reference manual for a quick reminder of how that will work for a triangle. So let me go ahead and show you that. So here we are on page 98 of the FE reference manual. As you can see, when we have a triangle that is facing this way, the x coordinate for that centroid is going to be 2/3 times the base from this end of the triangle, and then the y coordinate for the centroid is going to be the height divided by 3. So we're going to have to apply both of those to our triangle in this case. When you're solving these centroids problems in practice and also on the FE exam, that section of the FE reference manual that shows you the centroids for all sorts of different shapes is very, very useful. So I recommend that you become familiar with finding that page and using it appropriately. So in this case, let's go ahead and apply what we just saw to our triangle. So in this case, 2/3 times the base of the triangle would be 2/3 times 12 meters, which is going to be 8 meters in this case. Remember that the distance of that coordinate is going to be from 0, 0. I didn't specifically write out 0, 0 in this case, but we can know where it is. It's going to be this end of the shape. So then remember that we need to multiply that coordinate that we just found by the area of the triangle, and that would be 0.5 times the base times the height. So that would be 0.5 times 12 meters times 14 meters. Now for our second component, it's going to be more straightforward. We have a rectangle, and we know that the x coordinate for that centroid would be right in the middle. In this case, half of 21 is going to be 10.5. But then remember that we need to add this distance of 10.5 to the 12 meters, because when we write those coordinates in our formula, they need to be in reference to the origin. So in this case, the origin would be 0, 0, or this corner of the shape right here. So 10.5 plus 12 is 22.5 meters. And then we need to multiply that by the area of the rectangle. So that'll be 21 meters times 14 meters. And then remember that we need to divide everything by the total area of our shape. So we'll just add up the individual areas for the components. Once we put that in our calculator, we're going to get 19.3 meters for the x coordinate of the centroid. Now let's go ahead and solve for the y coordinate for the centroid of this entire shape. So if you take a look at the formulas, you'll see that they're actually exactly the same for x and y coordinates of the centroids. The only thing that we need to change is this 8 meters and this 22.5 meters. In this case, these were the x coordinates for the centroid of each component. So now we need to switch them out for the y coordinate of the centroid for each component. So in this case, let's start off with our triangle again. So remember that the y coordinate for the centroid of a triangle is going to be its height divided by 3. So if we do 14 divided by 3, we're going to get 4.67. So I went ahead and just wrote that in right there. And then finally, we need the y coordinate for the centroid of the second component, which is our rectangle. So that would be just halfway up the rectangle. That would be 7 meters right here. Once you go ahead and put that in your calculator, you're going to get 6.5 meters as your answer. So therefore, if we take a look at the multiple choice, the answer for this one is going to be B. Moving on to question number 3. Now we need to find just the y coordinate for the centroid of our shape. In this case, as you can see, we have a composite shape made up by a rectangle and a semicircle, and we're told the radius of the semicircle is 15 meters. So let me go ahead and show you how we can solve this one. So in this case, let's go ahead and split up our shape into a rectangle and a semicircle, as we can see here. And then we can start using our formula with each of these component shapes to solve our problem. So let's go ahead and fill out our formula, starting with our rectangle, our first component here. In this case, this one is going to be pretty straightforward. The y coordinate for the centroid of that rectangle is going to be half of this 30 meters. So it'll be 15 meters. And then we're going to multiply that by the area of our component. So it'll just be 30 meters times 30 meters for our rectangle. So dealing with that rectangle was pretty easy. However, we also have this semicircle. We haven't dealt with one of these yet. However, we can find some very useful information that'll help us out in the FE reference manual. So here we are on page 99. As you can see, here we have some formulas for a semicircle. We have the formula for the area and the x coordinate and y coordinate for the centroid. So let's go ahead and grab this information, take it over to our notes, and see how we can use it to solve our problem. So here we are back at our problem. So in this case, to fill out the rest of our formula, we're going to need to find the y coordinate for the centroid of the semicircle, and we're also going to need the area for the semicircle. So let's go ahead and use the formulas that we just found to go ahead and get those numbers. So first, let's find the y coordinate for the centroid of this component. I'm going to go ahead and call it y2. So the formula for the centroid on a semicircle specifically is right here, is 4a divided by 3 pi, and then a is going to be the radius, 2a is the diameter. However, remember that we need to add the 30 meters. So once we put that in our calculator, we're going to get 36.4 meters for the y coordinate of the centroid for this second component. And then we're also going to need the area of that semicircle. So I went ahead and called that A2. This is the lowercase a because it's just the area for the component. So we can use the formula that is right here to go ahead and solve for that area. So once you go ahead and put that in your calculator, you're going to get 353.4 meters squared for the area of this component. So now we can go ahead and place that in our formula. So once you go ahead and put that all in your calculator, you're going to get the answer is 21 meters. So if we take a look at the multiple choice, the answer is going to be D. Moving on to question number 4. Now we have a question where we need to once again find the y coordinate of the centroid. So let's go ahead and get started. So we're going to take a bit of a different approach for this one. Instead of splitting up this blue shape into 3 separate components, we're going to save ourselves a little bit of time by assigning our first component has this big rectangle here with the black border, and then subtracting from it this empty rectangle right here in the red border. So let me go ahead and show you what I mean. So let's go ahead and start off by finding the y coordinate for our first component, which is this rectangle with a black border. The height is 220 inches. So that means that the y coordinate for that centroid is going to be 110 inches. And then we're going to multiply that by the area, which is 150 inches times 220 inches. And then, like I said, now we're going to subtract the next part, which is this space made up by our second component. So first of all, we need to find the y coordinate for the centroid of this space. It is 200 inches in height, so that y coordinate is going to be 100 inches. So then we need to multiply that by the area, which is going to be 100 inches times 200 inches. So once you go ahead and put that in your calculator, you're going to get the answer is 125 inches. So if we take a look at the multiple choice, the answer is going to be B. Moving on to question number 5. Now we need to find the x and y coordinates of the centroid for this shape. As you can see, we have a circle cut out of the shape right here with a radius of 2 meters. So we're going to have to apply the strategy we learned in the last one of subtracting this component out. So let's go ahead and get started. So let's go ahead and split our shape into 3 components. We're going to have this rectangle right here, our triangle, and then we're going to cut out this circle component right here. So let's go ahead and start off by finding the x coordinate for the centroid of the entire shape. So if we start off with our first component, which is this rectangle here, the x coordinate for that centroid will be 3 meters, and then the area will be 6 meters times 6 meters. Now we need to find the x coordinate for the centroid of our triangle. So let's look at the FE reference manual once again, just as a reminder for how we can find that. As we can see here on page 98, when we have a triangle facing this way, the x coordinate for the centroid will be at the base divided by 3 from this end of the triangle. So in this case, the base of our triangle is 5 meters. If we divide 5 by 3, we're going to get 1.67. But then remember that we need to add these 6 meters because that coordinate needs to be from the origin, which would be this corner of our shape right here. So then also remember to multiply that by the area of the triangle, which would be 0.5 times the base times the height. And then now let's move on to this cutout of the circle. In this case, the x coordinate for the centroid of that component would be at 3 meters from this origin. We're also going to need the area of this circle. The radius is 2 meters. If we need a reminder for the formula of an area of a circle, we can go to the FE reference manual and grab that real quick. So this is going to be the formula right here. It's going to be pi times the radius squared. So once you go ahead and use that formula, you're going to find that the area of the circle is 12.6 meters squared. So let's use that to fill out the rest of this formula here and see what our answer is for the x coordinate. This right here actually needs to be a positive sign. So before we run that calculation, just needed to point that out. So we're adding these two and we're subtracting this circle right here. This is the component that we're removing to find our answer. So once we go ahead and put that in our calculator, we're going to get 4.8 meters for the x coordinate of the centroid. So now to find the y coordinate for the centroid of this overall shape, everything's going to be pretty much the same in the formula, except we need to have the y coordinate for the centroid of each component instead of the x coordinate. So let's just go ahead and just replace each one of those with the correct coordinate. In this case, for our rectangle, looks like that y coordinate would be 3 meters. So let's just go ahead and write 3 meters back in. And then for the y coordinate for the centroid of this triangle component, we know that it's just going to be the height divided by 3. We can go back to the FE reference manual if we need a reminder for that. So the height divided by 3 is going to be 6 divided by 3, which is 2. So this would be 2 meters. And then for the circle, the y coordinate of that centroid is going to be 3 meters again. So let's just write that back in. So then when we put all this in our calculator, we're going to get 2.6 meters. So now if we take a look at the multiple choice, the answer for this one is going to be C. Moving on to question number 6. Now we have one more shape. In this case, we need to find the x and y coordinates of the centroid once again. This time we have a rectangle with a semicircle cut out of it, and that semicircle has a radius of 15 meters. So let's go ahead and use everything that we learned so far to solve this last problem. So the way that we're going to approach the problem is by splitting up the shape into 2 components. we're going to have the rectangle and then the semicircle. So let's start off by finding the x-coordinate for the centroid of the entire shape. So first of all, the x-coordinate for the centroid of that rectangle would be 15 meters. And then we're going to multiply that by the area of the rectangle, which would be 30 meters times 50 meters. Now we're going to subtract this semicircle component. So first thing we need to do is we need to find the x-coordinate for the centroid of the semicircle. In the FE reference manual, we were given how to find the coordinates for a centroid of a semicircle, but the semicircle was horizontal like this, as you can see. This time it is flipped so that it is vertical. So what we need to do is we need to flip these two. So we're going to use this right here to find our x-coordinate instead of this. So let me show you what I mean. So we're going to use this formula right here. We need to subtract that from 30 meters because that is the length of the entire shape, as you can see here. And then the x-coordinate of the centroid is going to be right here where this red dot is. So once you put that in your calculator, you're going to get 23.6 meters for that x-coordinate. And then we're also going to need to find the area for that semicircle. So let's use this formula right here to find that. Once you put that in your calculator, you're going to get 353.4 meters squared. So now we can use that to complete this formula and see what that part of the solution is. So once we put that in our calculator, we're going to get 12.3 meters for this one. So now let's find the y-coordinate for the centroid of the overall shape. In this case, the formula is going to be the exact same, and we just need to switch out these x-coordinates for y-coordinates. So in this case, the y-coordinate for the centroid of this first component is going to be 25 meters because the height is 50 meters. So half of that is 25. And then for the second component that we're subtracting, the semicircle, we can use these visual annotations on the diagram, and we can see that this is going to be at 30 meters. So let's go ahead and write that in. So once you go ahead and put that in your calculator, you're going to get 23.5 meters for the y-coordinate of the centroid of this overall shape. So if we take a look at the multiple choice, the answer for this one is going to be A. So that brings us to the end of this section on centroids of area. I hope that it was very helpful. As you can see, these problems are pretty straightforward once you understand how to use the formulas and once you understand the concepts. When you are ready to move on to the next section, we are going to be covering area moments of inertia. So I will see you there.